So I'm just going to go through the process to show you how these Unit 2 answers get marked, and thank you very much, Ellie Richards, for allowing me to use your work. It's very good, so it's quite an enjoyable piece of work to mark. So just going to go through and kind of show you how this works. Of course, it's marked in a level system. So this first question, which is about describe the aim and theory behind your data collection, is out of 5 marks, so 2 levels. First level up to 3 marks, and then the second level sort of 4 and 5 marks. So here we go. So the aim of the investigation is to compare the characteristics of the Bradshaw model. There we go, that's great. I'm picking that out because that's good. Geographical model, characteristics change downstream, so good explanation. So already, well, pushing into level 2 already. So wetted perimeter, all those different things. So a little bit about American rivers, which is interesting, but I'm probably not going to award any extra marks for it. And then so describe what the theory is there, and then why you chose it down here, which is coming on here. So as time was limited, that's great. Anything to do with time is always going to get you marks in geography. Easy comparison, 4 sites, that's great. That's a really good answer. So straight up, I can give that a good mark. So I'm saying that's 5 out of 5. Great, thanks very much, Ellie. Okay, so moving on to the next one. So this question is asking you to state your hypothesis and then one method of primary data collection. So it's out of 8. So 8 is about the highest number of marks that's awarded in the second half of the Unit 2 paper for a single question. So it's quite difficult to get those 8 marks. So with 8 marks, there are 3 different levels. So sort of level 1 is 1, 2 and 3 marks, level 4, 4, 5 and 6, and level 3, 7 and 8 marks. So it's always going to be difficult to get those. So what's going on here? To start off, our hypothesis stated the particle size would decrease. Great, that's already 1 mark for stating a part of the hypothesis. In order to prove or reject the hypothesis, we collected and recorded sediment samples the sites along the River Corfe. We used random sampling. Yeah, great, good piece of explanation about method of data collection. Why is random sampling good? Unbiased and accurate, really reinforcing it. So already I'm getting the idea that this is a strong mark. I'm going to get a strong mark, so I'm already looking at sort of level 2. So it goes on here, and now what I really just want to see quickly is some sort of explanation as to why particle size may change downstream. So I'm not seeing that, which is quite a high level piece of information to get in. So I'm not seeing that, but I'm going to carry on reading to see what else there is. So in order to follow the random sampling technique, we chose 10, but I don't really need to know that. I know what random sampling is, so I'm not going to credit that. Once having collected 10 pieces of sediment, we can compare the size and angularity. That's really good. Powers of index, that's a really good terminology. So this is again reinforcing what a strong answer this is. We're to collect 10 pieces of sediment, 4 sites. However, on the day, a collection process, we experienced some limitations. Okay, that's interesting. That's a kind of another layer that's been added into that. Which I quite like. Lots about the limitations. I wonder if there's not really anything written there. Simple thing about how we wrote the data down. That would be quite interesting to know. But it says another limitation about the silt being too small, which shows a sample to produce accurate results. So this is a solid answer, but there's just a couple of things that are missing there. I think particularly the explanation as to what you were hoping to find. Just very briefly would have pushed it up into level 3. Maybe something very simple about how it was noted down. Perhaps working in a pair or something like that. So I'm going to probably give that a 6 out of an 8. So it's a good answer, but just not quite good enough to get into that top level. This next question is a 7-mark question, and you have to describe in one method of data collection and say why you chose it. Okay, so again, 7-mark question. This would probably just be 2 levels, one from 1 mark to 4, one from 5, 6 and 7 marks. So I'm looking first of all for a description of a method of data collection. Here we go straight away, ArcGIS. Now, as a marker, I'm already thinking, wow, ArcGIS, that's a really high-level piece of presentation. This is going to be a good answer. So most students, they're probably writing about a bar graph or a line graph or something. So an ArcGIS mark, ArcGIS answer is really, really good. So we use the computer program ArcGIS, present the data, collect a specific point, click again. So great description, that's great. ArcGIS allowed us to place a proportional symbol on the map. Okay, that's good description there. And it's located as well, which is one of the real strengths of it. So already we're describing and saying the strength at the same time. So it's allowed us to put our four sites. That's good. We know about those. It's a quick method, easy for comparison. That's a strength there. Then, for example, we showed how the gradient changed downstream. That's a really good example, practical example. Could use this, placing the pins at each point. Using the key to show a range of results. This method was extremely useful in allowing us to compare our data at multiple sites, give us a good understanding of the change. I'm sort of getting the impression now there's a little bit of repeat going on here. It's also very clear, easy to read, allowing for quick evaluation. That's great. On the other hand, there are some limitations. The question isn't really asking you for limitations, so this is maybe a really high level point. So you're saying that it's difficult to get lots of pieces of data on one map, so that's quite good. So I'm tempted to give that full mark 7 out of 7, but I just think it's a little bit repetitive. Maybe there was some more description that could have gone into there, exactly how you went about placing the data or on the map using specific longitude latitude figures, or drawing it from a Excel spreadsheet or something like that. So I'm going to give that 6 out of 7, which is still a really strong mark and a good answer. Well done, Ellie. This next question is all about analysis, and it's state the advantages and disadvantages of method of analysis that you used, and it's 8 marks. Now, I think these analysis questions are probably the hardest of the lot, actually. And what we're looking for is, once you have presented your results, what techniques, what methods did you use to actually unpick what they meant. So what I'm looking for here, ideally, I think, is probably some sort of mention of Spearman's rank, or chi-squared, or central tendency, or maybe interpreting it from a line of best fit on a scatter graph or something like that. So let's kind of see what Ellie's got in here. So she comes in and she states the fact we've got ArcGIS, we've got log. Okay, that's presentation, that's of interest, but it doesn't really gain any marks. Okay, kind of gone through and sort of continues to explain what's happening. That's fine. Okay, this allowed us to compare. The ArcGIS allowed us to compare data. Okay, so we're sort of got scoring marks now, because it's good understanding. On the other hand, there were some limitations, advantage, disadvantage. Okay, from the previous answer, that's coming through, but we still give that credit because it's marked, separately. So each symbol got to reflect the distribution. It's hard to get them on the same map. Okay, that's fair enough. But I'm not really getting a great sense from that it's analysis. It's kind of some quite general points that could be applied to lots of things. So I'm not that keen on that answer so far. But anyway, we go on. Our second data collection method, we used the long section. At the top here, sorry, use a long section and cross section. Both of these are types of line graph. Okay, I'm just scanning through here, cross section at each side, and it's quite, once again, this allows easy comparison, very similar to what we've just read in the previous one. We also had to be extremely careful when plotting our data. Okay, that's some fine things there. But what I really want here is actually some mention of the data. I'm looking for the word anomaly. I'm looking for the words for things like pattern, for correlation, and I'm not seeing that. I'm sorry, Ellie, about that. But that's what I'm looking for. We used the Holstrom curve to show the velocity of sediment and transport. Data collection method was very useful. Did not have a large range, and therefore, okay, didn't have a large range. That's good. That's good there. Clearly showing quick analysis experience limitations often the data have a. Okay, so I think, to be honest with you, I'm going to have to be quite generous and probably give this a 4. Let's talk more about the presentation methods and actually the analysis. So, I guess a typical question of falling down on these hard analysis questions, because we are looking for evidence of how you analyse the data using generally some sort of mathematical statistical formula or something like that. So, but never mind. Ho-hum, we'll carry on. The next question asks you to summarise your findings and mention some improvements. Again, another 8-mark question. So, shooting high, Ellie, that's good. I like that. Summarising and then also saying improvements. So I probably want some specific data, but not too much. But basically, going back to the hypothesis and seeing what you found out. So after analysing our results, we could see that the river course did not match the Bradshaw model. All right, so scoring some marks. postulated river gradient would increase downstream, and that's what it did. Apart from, wow, look at this, the nick point. Okay, so great. So lifting yourself into some high-level explanation there. So it didn't fit the model. Why was it? Because there was a nick point. That's great. Okay, so that on its own obviously doesn't going to get you into the top level, but it's giving a strong indication this is a good answer. Hypothesis 2 about velocity, similar things again, stating some data. This word outlier here is great. That's good to see. And then moving on. So sorry, moving on. Eightfold increase, good way of sort of saying, again, summarising it, etc. etc. An anomaly would have been caused by. This is great description. Probably a little bit too long, to be honest, because it's only asking you for a summary, but you've got unlimited time here. So I think in under time circumstances, you would want to cut this right down, because remember, you've got to finish this paper. So it's so important to finish the paper. And then the second half of the question, which is about improve, we come down here to score more marks. So if you stopped the answer there, okay, if we just didn't have that, you're probably looking at maybe a 5 out of an 8, because you've only answered half the question. So now we're looking at improvements to try and get the last 3 marks. So to improve our findings, we're to collect more data. Okay, that's good. Reduce the risk of anomalies. I would have had also investigated more sites. Okay, these are common things that we said, but I'm looking for specific things. I would have used a chain, okay, to instead of a tape measure, to measure the wetter perimeter, eliminating problems. Okay, that's great. That's good. Okay. I think that's nice. I believe our results would be the best if we could have collected our investigated time. Okay, so some standard things about time there. I'm gonna limit that at a 6 out of 8, and the reason I'm going to limit that as a 6 out of 8 is because the improvements are quite generic. I would like something a bit more specific. I think that I would expect from where it talks about the chain, using the chain, it's just to actually drop in the information about what your wetted perimeter figure is, and say perhaps that you'd expect it to be a little bit larger or a little bit smaller if you use that tape measure. Okay, so 6 out of 8, they were very, very good, a very, very good answer. So well done for that one, Ellie. So 5-mark question to finish. How do you use your findings to improve your understanding of the topic? So quite a sort of, they often like these fairly sort of open, slightly ambiguous questions at the end of the paper, but definitely make sure you've got to get through this. You've got half an hour to write this second half. You've got to get through to this last question to make sure you get the most out of the paper. So overall, our results showed that the river course did not follow branch model. That's great. So another mark there. Some aspects of sediment size did not vary. Investigation not only blah, 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 blah. Case mentioned understanding of the topic. That's good. Oops. That's good. It helps us to fully understand the meaning of long profile and cross profile. Okay, that's great. And the link between several processes. That's good. So link between river velocity and competence. That's really, really good. What I found most useful by studying the river course allowed us to gain an overview of the river, similarities and difference to what we expected to see. That's great. Also showed small natural occurrences such as the nick point. Okay, great. I mean, I've said this has cropped up before, it will always get you marks. Okay, this is more specific information. By picking site 4 to investigate, surely studied during the upper course, allowed us to use. Lastly, it helped me to comprehend if the different landforms that occurred, so meanders at site 4. Great, good. Okay, so there's been some really specific information there relating to proper places and what you found out. So that's great. So I'm going to give that a 5 out of 5, which is a good mark to finish. Well done, Ellie.